Today we're going to solve a problem involving a quadratic equation. So we need to form a monic quadratic equation which has solutions x equals 9 and x equals -6. And then we need to express the equation in expanded form. So let's start with the first part. Now we remember that a quadratic equation is an equation that contains an x squared term as the highest power of x. And a monic quadratic equation means that the x squared term has a coefficient of 1. So the question is asking us to work backwards. So if we remember, when you solve a factorized quadratic equation, such as x minus 1 multiplied by x plus 3 equals 0, we would set both factors or both expressions inside the brackets to 0. And then solving these two mini equations, we get x equals 1 and x equals -3. And these are our two solutions to this quadratic equation. All right, so then if we look back at our question, we're given x equals 9 and x equals -6. So we want to form two equations with the right hand side equaling 0. So what about if we take away 9 from each side of this equation? We get x minus 9 equals 0. And similarly for this equation, we get add 6 to both sides, which gives us x plus 6 equals 0. So now we have two equations, mini equations, which then we multiply together, and that will give us a factorized quadratic equation with solutions x equals 9 and x equals -6. So we're on the right track. Now to the second part, which is to expand this equation. So remember, we can use the FOIL method, where we multiply together the two first terms. So x multiplied by x is x squared. Then the two outside terms, so x multiplied by 6 is 6x. Then the two inside terms, -9 multiplied by x minus 9x. And the two last terms, so -9 multiplied by 6 minus 54 equals to 0. Now all we need to do is collect the like terms, which gives us x squared minus 3x minus 54 equals 0. And there we have an expanded quadratic equation. And you'll notice that it's a monic equation because the coefficient of the x squared is 1. And that's the solution. Well done.